Hello friends! Welcome to Coding Garden with CJ. Welcome to something I've never done before. So last Friday I did a live show at the DVLP Denver conference, which is a conference held annually here in Denver, Colorado. And I did a live show in front of 20 or 30 people, and I recorded it, but I wasn't able to stream it at the time because the Wi-Fi wasn't the best. So what I'm going to do is I'm going to play it. This is not live. I'm live, but the video is not live. So I'm going to play the video, and I'll be here. I'll be interacting in the chat, and every now and then I might pause the video to give some commentary. And feel free to, like, if you spot any like coding errors or anything like that, feel free to throw it in the chat, because I will definitely acknowledge you. Let's say hi to the people before we get started. Hello, Andrew Lane. Welcome to the stream. Hello, Amy. Welcome back. Hello, Wally. Hello, AR. Alicia. Welcome to the stream. And Renzo. Hello. Welcome. And Andrew Lane. Did I already say hi to you? Yes, I did. Hello. And Ryan. Good evening. Who wants to take bets on how many people will show up and ask if this is live? Place your bets now. I don't know. I bet there's going to be quite a few people that are like, is this live? It's not live. And I'll be in the chat to tell them that it's not live. But here we go. There's this. Now it's me on top of me. I'm going to go away. Yeah. Okay. I'll press play, and then every now and then I might pause it and add some commentary. Here we go. So go to that URL. It is a poll, and we'll be answering questions and informing what I will build today. While you're doing that, hello, my name is CJ. I'm a full stack developer, an educator, a maker. What do I do? I started a new job on Monday at 303 Software. It's a consultancy here in Denver. For the past 3 years, I was an instructor at Galvanize, teaching in the full stack immersive program. And for the past 9 months or so, I have been streaming myself on YouTube. So several days a week, I go live on YouTube and build apps and solve coding problems and all sorts of fun stuff like that. So today is going to be that, but with all of you wonderful people in the room and not on the internet. Yes, so when you go to that URL, you should see that I'm going to start the poll soon. Raise your hand if you have not gone to the URL. Raise your hand if you're not going to the URL. Cool. Okay. I think it's a good enough representation. Let's see what happens. Okay. And I think I can go to results here. Okay, so first question is, what should I build? So the options are tic-tac-toe, minesweeper, or snake. Vote now. Well, it's randomized. I guess we don't know what's what. Also, I will say this is live. I didn't really prepare much. All the code that I write, I'm going to write right now. I'm probably going to make a lot of mistakes, but hopefully it will be entertaining a bit. Is that everybody that's going to vote? Get your votes in now. Okay. How do I know what is what? Next question? Yes. Oh, no, I'm going to build snake. Cool. Okay. So we will build snake today. That's going to be fun. All right. Next question. What should I build it with? The options are vanilla JavaScript, React.js, or Vue.js. Please vote now. What's it? Is it vanilla? Let's see. What is it? React.js. Okay, so we'll do it in React. Sounds fun. Yeah, like I said, it is randomized. We don't know which will be which. Okay. Next question. What? Oh, no. Go back. Hide answers while polling. Oh, well. Oh, there we go. Okay. So, regardless, which browser API should I use? Can you guys vote for that right now? Cool. Yeah, so I actually just read about shape detection last night. It's built into the, Chrome, at least, under a feature flag. It can detect faces and images. I don't know how we're going to incorporate that into Snake, but we will, if that's what's chosen. Ugh. And all of a sudden, my camera started showing ads. I don't know if there's anything I can do for now. Actually, can you guys see the results on your page? No, okay, keep voting. It's too late now. Or is it? I don't know, I could probably add the audience. Yeah, let's add the audience. No, I got this. I'm a professional. It should be Logitech. Did it light up? Okay. All right, it's too late. We won't be able to see their faces. Okay, what did you all choose? Oof, it's a tie. Okay, between the gamepad API and shape detection. We'll do a tiebreaker at the end of all these polls, but those are our two choices. Okay, and then the last one is a fun one. What constraints will I have while building it? So your choices for constraints are functions can be no longer than 2 lines, no variables, no dev tools, and then also I can only run the app once at the end. So I literally cannot see it in the browser while I code it. Which will you choose? Oh. All right, let's see what you got. Can only run the app once at the end. This is gonna be interesting. Okay, so I have to build the whole thing. I cannot view it in the browser. I guess, honestly, like, it may be less entertaining for you all because it's just code that you're gonna be looking at. But, okay, so I have to code the whole thing. I guess I get one chance to run it. I'm sure if it doesn't work, I might debug it a little bit, but yeah, let's code the whole thing. Cool. All right, and then let's vote on gamepad or shape detection. Let me add a question really quick. Okay, vote now. So should I use the gamepad API built into the browser or the shape detection API built into the browser? Which is it? Shape detection. Okay, I read like one blog post on it last night. We'll see what happens. Shape detection. Okay, this will be fun. So the app we will build will be Snake. It's going to be with React.js. We'll be using the shape detection API, which is built into the browser. And I can only run the app once at the end. So I'll have to write all of the code, and then at the end, we'll put it in the browser and see if it works. Cool. So we voted. That's great. Next, let's make a plan. Any thoughts, comments, questions before we get started? Also, feel free to like yell obscenities at me or funny things. I don't know. This is live. Usually, I'm interacting with the chat. And feel free to like point out typos or bugs or tell me that I have a horrible plan or something like that. Okay.
Feel free to reach out. I'm just going to write on my phone and just show it.
Okay, I can't read it, though. All right, but let's get started. The next thing is at 10. So I'm going to set let's do like a 30-minute timer, 35-minute timer, and we'll see what happens. So we'll start that. I think I can like pull this out, full screen it. Okay, so there's that. Oh, and actually, I guess I can't use the browser. So I can use the browser to look up docs. I'll go ahead and say that, but I can only run the app once at the end. Cool. Okay, so the plan. So we need to make Snake. I guess first plan is let's create a React app. And I guess, so if we think about snake, it's a grid, right? So like rows and columns. And there should be an apple that pops up in one of those rows and columns, and then you have a little dot that moves around the screen. So let's maybe get a grid on the screen. Well, we won't have a screen, but make a grid. Cool. This is like the worst constraint. Can we vote to choose a different one, maybe? Yes, sure. What were the others? I don't know. I can do it. It's just gonna be tough. So functions can only have 2 lines, no variables, and no dev tools. I can do it with no dev tools. Never mind. We're gonna keep going. Okay. So make a grid, and then Brooks, can you be the designated camera tapper? Cool. I don't know what happened. I think maybe, well, so just sit right there. Yeah, and then whenever the ads pop up, tap on it. Yeah, I don't know. It's never happened before. Okay, so we need a grid. We then need an apple will appear at random. So we make the grid, and then when the app starts up, there should be an apple somewhere in that grid. We then need a starting, we need a snake. So there should then be a snake somewhere. Maybe it starts off at like the center of the screen. And then we need some sort of like game loop, like a tick, right? Because like on every tick, the snake will either be moving forward or backwards or up or down. And if you've ever played Snake before, essentially like whatever your direction of travel is, you just start going in that direction. So some sort of like game loop. I don't know, I'm being extremely generic. We'll see what happens with the code. And on each tick, so the snake will probably have some velocity, either like an x velocity or y velocity. If it's like positive x, it's going right, negative is left, y, etc. We'll then have the game loop, which will be ticking and moving the snake. Move snake. And then check if collides with apple. And if it does, grow snake. And then reposition, well, re-add apple at random. Okay, am I missing anything? Does this sound like a good plan? Is this too generic? Can anybody think of anything that I did not think of? Self-collision. That's going to be a stretch goal. Let's say you can run into yourself for now. Okay, but I like your thinking. Keeping score. I will say growing the snake would probably be your score, but I think we can like show length of snake. Like it's 3 long, that means you've collected 3 apples. I like it. The stretch dies if it collides with itself. Oh, hello. So I think what I'm going to do is keep a running to-do list of some of the things I forgot to do or some of the things I want to do after. Because after I show this video, I want to like fix the code because reasons. So let me I pull up just like a README, because one thing I forgot to do was show the length of the snake on the page. So let's make sure we do that. Show length of snake, like the score, because I totally forgot to do that. Okay, sorry for the interruption. Back to it. Ooh, yeah, so that's one thing I didn't think of, like what is the frame rate here? Like how fast is it moving? I think I can actually incorporate that. So like in our game loop, we have like some sort of frame rate. Like if velocity is 1, is it like 1 pixel per second, or is it like 10 pixels per second or something like that? Cool, what else? You have 39 seconds. Actually, is there water? I'm gonna get a water. If at any time you can't see my code, please let me know. I'll try to zoom in or change the contrast or something like that. This is my break timer though, so everyone reach into the sky, take a quick stretch. This is perfect, it's lining up with the timer. All right. Let's do this. Okay, step 1, create a React app. I think I have the latest version of the React app. Do I have create React app? Okay, cool, so I don't have to deal with the network. And we're gonna call this snake. Enhance. Bigger. Okay, so that's creating the React app. We gotta let it spin. It is having to do an npm install. It's not bad though, I got 80 kilobytes a second. How was your night? You guys drink a good bit? No? Anybody hungover? Who's hungover? Wow. Well, I guess we all made it here at 9 a.m. So. Yeah. Did not anticipate this. So this is a talk on creating a React app. We'll just sit here while it generates. Okay, in the interest of time, I'm just gonna start on like styles.css. We have nothing yet, but I'm just thinking about the grid. So we probably have like, we'll have like a game area. We could do like responsive width and height or something like that, but let's make it fixed width, because then we can do, let's do like 5 by 5 pixels. And so we probably don't want it fixed width, we'll hard code it for now. So like, let's say width of the game is gonna be 200 pixels and the height of the game is gonna be 200 pixels. And then there will be cells inside of this game grid. Let's call this grid instead of game. Just tap the screen. Thank you, Brooks. Let's give Brooks a round of applause for tapping the screen. Great, cool. And then we need cells inside of the grid. Let's make those, I guess we'll make them 10 by 10, so we'll have like a 20 by 20 grid. So 10 pixels, height, 10 pixels. Let's give the cell an outline of like 2 pixel solid black. So we have our grid, 200 by 200. We have our cell. Let's make the app itself be a flex box, and we'll just like put that grid right in the center of the page. So we'll do justify content center align items center, and we'll have a width of 100% and a height of 100%, and the body will have 100 view width, and a height of 100 view height. So we've got our main app area, takes up the whole screen. We then have our app component, which we're gonna write, that is a flex box. It'll be centered, all of its items will be centered directly in the middle of the screen. And then our grid, which we're gonna put inside of that, is gonna take up 200 by 200. Maybe we'll come in and change this. And then each cell is gonna take up 10 pixels. I like that. Let's say the apple has a color of red. And really any cell, if we give it the class apple, it'll just show up as red. And then let's say the head of the snake has a color of, pick a color. Blue. Okay, so the head is blue, and anything in the tail is, pick a color. White? Light blue, okay. I like it. It's like white, I think that'll be the color of the grid. Cool, so we've got a grid area, we have the apple, which will show up on the screen, the head, can everyone hear me? Am I talking close enough, Mike? Cool. The head of the snake and tail of the snake. We have a React app, cool. I guess I can start it up, but I'm gonna have to close my eyes while the browser opens. Actually, I won't start it up, right? We just start it at the end and see what happens. Okay. So now that I have all these styles, let's use them. And if we go into our React app, we have our app.js. Hello, hello, hello. Okay, I just noticed something. In the styles, I put color instead of background. Like, so for the apple, the tail, the head? Yeah, I had color in the CSS, so that actually needs to be background. Color in CSS should be background. Okay, glad I caught that. All right, back to the video. Let's get rid of that React logo. Let's get rid of this. I just thought of something else we need in the styles, but we have that div with the class name of app. We then will have a section inside of there, and that section will be the grid. Grid. And then we'll need to create the rows and columns, and they're all going to be 10 by 10 pixels. Let's go into our app CSS and just throw in all those styles that I just created. So like, let's get rid of all of that. Those styles I created will go there so we can use them. Really, we need to do class app is the 100%, and then div app, or ID app has width and height of 100%. We're in React.
Everyone following. Did I do something weird in these styles that I did not anticipate?
Yeah, so in the CSS, React uses ID root, not ID app, so I need to fix that too. Okay.
Okay, potentially. No? Okay, we'll keep moving. Okay, so that's our styles. I think we're just gonna do this all in one component just to make everything easy. So we have the grid. We need now, if we're hard coding it, what's 200 divided by 10? 20. So we need 20 rows across and 20 columns. So we need an array of length 20. So let's think about this though. Does this need to be in state? So we have rows and columns. We pretty much need to keep track of like which row and column will have which snake in it. We could do like, okay, so we could generate the grid, and then the apple and the head could be in like fixed position. I don't think I like that though. Let's put it on state. So our state, we'll do this in the constructor because I want to write some for loops. So this .state is going to have the grid, which will be an array of arrays, like rows and columns. Yeah? Yeah? Grid? I'm psyching myself out. This is not going to go well. Okay. So we have our state. We have grid, which is going to be an array. And then we need a for loop that'll go to 10, and a for loop inside of that will go to 10. So that'll go up to 10. Yeah, I like this, because then we have the coordinates, row and column, and then we can add the class to that row and column if it's a tail or if it's an apple or something like that. So then we need to push in some sort of cell, and the cell will have row and column. So let's call this, we'll do row, and then we have a for loop for column, and that's going to go up to 10 as well. And then in our grid, so first we need to create a row array? What? Row. I gotta name it something else though. Let's call it columns, because it'll have all the columns in it. Okay, so, and then columns, we're gonna push in an object that has a given row and column. So the row and column, like 0, 0, 0, 1, etc. And yeah, I think that works. So now we have an array with rows and columns in it. Well, we have an array of arrays. Then we can iterate over those to show them in the grid. And then we'll have some conditional logic that says, like, if the row and column is this, add the apple class. Otherwise, add the head or the tail class. Am I missing anything? Is that horrible? Who hates me for doing this? No hands are raised. Cool. So we have that. And then after you have a column, we need to push that into the grid. So we'll say grid.push the columns. Cool. And then we'll put that on state. So let's just put state after we've created all of that. Good call. 20, yeah, because each cell is 10 pixels, so it should be 20 by 20, right? Good call. Thank you. Oh, okay, so we have our grid array, we're pushing the columns in the grid, and then state will need the grid on it. What's wrong with this dot state? This is not allowed before super. Cool, so we created the grid. Now in our, that is so hard, I apologize how hard this is to read. Keep moving. So inside of the grid, we need to do rows and columns, so I'll do this dot state dot grid dot map. And that's going to give me each row and some index. We can use the index as the key because the grid is static. And then inside of the row, we're going to map over row. So we'll say row.map. Oh, actually, this will be row num, right? Oh, we have access to the row num. Never mind. So map over the grid. That's going to give us each row. And then we'll map over the that given row, which will give us the column. It's called, no, it's a cell. This gives us the cell. And then we'll just return a nice little div that has a class of cell, because that should show up with the outline, and it should be 10 by 10 pixels. And I can't even view this in the browser. That's crazy. Okay, so, but if we did everything right, imagine we have a grid, right? Am I missing anything? This should give us a grid, right? So I have a 200 by 200. This will not give us a grid. Notice, I'm not returning the row map. I have curly braces instead of parentheses. So let me make a note of that. Grid in render return row map, because otherwise it doesn't return anything, so it won't even render, right? I think I meant to put parentheses, or I could put a return statement there, but I think I meant to put parentheses and put curly braces instead. Okay, I'll go away now. I have a cell that's going to take up 10 pixels each, and because these are divs, we need to make them inline block, right? Because if we do, if we make them div, if they stay as display block, it's just going to be all down. So a cell should be display inline block. And for those of you that are joining, I am not allowed to view this until the app is done. So I have to build the whole thing, and then we'll see what happens. Okay. So that should be we have a 200 pixel container, 10, 10, 10, 10, 10, 10, 10, 10, 10. We get that stuff. Great. Now we need the apple. So when the app starts up, let's just say the apple is going to be an object that has like row and column. And row will be something random from 0 to 20, and column will be something random from 0 to 20, right? Okay, so let's do math.random times 20. Is that how that works? 0 to 19. Yeah? Cool. Why not? Is this wrong? Someone tell me this is wrong. Will this give me a random number between 0 and 19? I need to round it, yeah. So we'll do like math.floor, right? We only have 17 minutes. It's fine. It's fine.
Do you want to start at 0 or 1?
What's that? What?
It looks like you're going through all of it and just chunking in cells, and there's something that says go to the next row.
Yes, but because of their size, they should all show up. Yeah, so because it's in a container, it should be 20, 20, 20. Yeah, cool. So the apple will show up when the app starts at random. And I do want it 0 to 19. Is that what you asked?
Yeah.
Yeah, 0 to 19, because that's our rows and columns start at 0. Cool. And so when we're mapping over here, we can do like a conditional class. So okay, I don't know if I ever update that, but the random apple should be math.random times 19, because that would give me a random number between 0 and 19. Somebody in the chat, is that right? I think that's right. I'm gonna update my to-do. So yeah, Shivanshu's saying this is why you should test often. I can't though. So the constraint that they chose was I literally cannot run it till the end. Let's just double check random Apple logic. Should be 0 to 19. Okay. It's so funny. Like when you're seeing things from the outside, you catch all the errors you didn't catch before. Okay, here. So we'll basically say if the row and column is equal to Apple row and Apple column, give it the Apple class. So let's do this. One of those. So we'll do a template literal. We absolutely want this to be cell, but we'll say if let's destructure this. So we want the grid. We also want the Apple from state. So now I can just say grid, and then I can say if Apple dot row is equal to cell dot row, and Apple dot column is equal to cell dot column, then we should give it the Apple class. Otherwise, nothing. Can we format this? I guess we can. We can do, because it's a template literal, we can new line it. Break timer, reach into the sky.
You're using div class. I don't think you can do that.
We call it class name, right? Yes, so all of these should be class name. Cool. There's that. There's that. Okay, so if the row of the Apple and the column of the Apple is equal to this given cell, it's going to have the Apple class. Cool. We should see some red thing in the grid. Imagine it in your mind's eye. Okay. What's that? You see it? Awesome. Okay. What's wrong with this? Unreachable code detected. That goes there. Oh, that's why everything was. I thought my brightness went down for a second. Okay, so we've got the grid. Okay, now we need some gameplay, right? And I'm not even looking at my checklist. Okay, so we created a React app. We made the grid. An apple appears at random. We now need a snake. So let's say when the game starts, we have the snake, and the snake has, let's say a head, and head will have a row and column. What's 19 divided by 2? We want it in the direct center. 9.5, so we'll do 9, right? Because it's 0 to 19? 10. Because that's 20 numbers, right? What? 9? Okay. So this should put the snake, it doesn't matter as much, but this should put the head of the snake at the center of the grid when the game starts, right? Cool. And so then we need some more logic in here. Can someone think of a better way to do this than like these ternaries? Because it's going to get pretty complex, because otherwise I'm going to have to do like if apple.row equals cell.row, so apple, else if snake.head.row is equal to cell.row.
Why don't you break that up to a function?
Good call. Yeah, so we can say, I like it. Okay, so if this is apple with the given cell, I like it. So we'll do like this dot is apple. And so on our React app here, we need is apple that takes in a cell and just returns this. Cool. And this should be we'll grab apple from state. Excuse? What? Okay. Sorry, I can't hear. Okay, that's cool. And then we need another one for like is head, and that takes in the cell. And we'll do something very similar. So let's grab the head from state. If we'll say, oh no, sorry, well snake. So we'll grab the snake from state, and we'll say if snake.head.row is equal to cell.row, or if snake.head.column is equal to cell.column, then it is the head. And then we also need another one for is tail with the given cell. We don't have that yet, but we'll leave it empty. So if it is the apple, give it the apple class. Otherwise, if it is the head, give it the head class. Otherwise, nothing. Cool. So now our player and our apple show up on the screen. Great. Now we need a game loop. And I'm not using apple anymore, so we don't need that. Okay. So now we need a game loop. So let's say like in component did mount, we start doing like request animation frame. Who's taking bets on if I'm going to be able to complete this or not? Who thinks I can finish it? Oh, appreciate the confidence. Okay. So when the component mounts, we need to let's create a function that's called just like game loop. Game loop. And this will increment velocity and things like that. So our snake will also need, we'll have like a velocity property. Let's say like our x velocity starts off as 1 and our y velocity starts off as 0. So when the app starts up, it should start moving right. And then it also needs a position. Well, I guess the head, oh, it has a position, row and column. Cool. And it has velocity. Cool. So here's what we'll do. We'll do request animation frame with this.gameLoop. So this is built into the browser. Basically, it recalls that function. I can't explain it that well, but it calls the function when it should be, and then we can call it again. So this essentially is like call the function, and then when it's done, call the function again. And so this is going to run over and over and over again. So inside of our game loop, we now need to move the head of the snake. So here we'll say this.snake.head .column plus equals its velocity, right? This.snake.velocity.x. And then we'll do the same thing with the row, velocity.y. So essentially, this is constantly moving. Actually, instead of request animation frame, because that's going to be moving super fast. We talked about frame rate earlier. Let's just do like a set timeout and call it every second. So it's going to move like one at a time. I guess technically I could probably do that with request animation frame, but yeah, that cool.
Do you want set timeout or set?
Set timeout, because then I'll call it again after it's been called, like that. Cool. I'm probably gonna have some binding issues in here. I just know it. Yeah, let's make all of these functions arrow functions, just so our binding works. That's one thing I didn't take into account, and one thing I can't check because we're not running our code till the end. Okay. Cool. Got our game loop. We're just doing this because we need the context of this to be consistent. Okay, so this should move our snake. Like when the app starts up, it's going to increment the row and the column of the head of the snake by its given velocity. However, we have an issue. When it reaches the end, does it die or does it wrap back around? Okay, raise your hand if you want the snake to wrap around the screen. Raise your hand if you want the snake to die when it hits the edges. It's a little bit more. Okay, it's going to die. So if the column is greater than 19, that means we have reached the edge of the screen. So let's do like our collision detection here. I guess I don't have that in my checklist. So it has velocity. Yes, so if it's less than 0, then it went off the other side, definitely. We have our game loop. Now we're moving the snake. We will need to check if it collides. So actually, let's do the edge detection logic first. Okay, so if you could write a function. I don't know. We could do it all in line. I'm panicking. Okay, if this dot is off edge. Yeah? I don't know. Return. Game over. And then let's just do like a set state. Oh, and I cannot directly modify state like this. I need to do a set state. What am I thinking? So this dot set state. Did anybody catch that? You're tired? Is that what you said? Okay, so snake needs to be equal to, and really I need to use the previous state. Let's use a function here. So we have our previous state. And we're going to need to, we're going to set state. We need to update the snake. The snake is going to be equal to itself. However, prevstate.snake. Let's extract it. So copy all of the snake's properties. Actually, no, let's do this. Let's say head is equal to, we'll just do this, row and column. So this will be snake.velocity, so snake.row plus that, and then snake.column plus that. Thank you. Call. Okay, so on each game loop, we're updating the row and the column of the head. That's the only thing that's being modified right now. And this, I'm destructuring the previous state to grab the previous row and then adding on its velocity. Okay, cool. So that updates the velocity. And then we're going to need a callback function here, because then we can be guaranteed that state has the latest values, and that's where we'll do all of our logic inside of there. So we'll say if this dot is off edge, then this dot set state game over is true, and just end it there. Otherwise, we'll do our so we did our collision detection. Otherwise, we'll say if this dot collides with apple, eats apple. I don't know. So if it collides with the apple, then we need to do some stuffs. So we need to, I don't know, a lot of things. Let's get, let me just, what's that? Increase the length of snake. Okay. So if it collides with the apple, yeah, this is like where this is the core of a snake app, right? Like this is where it gets tricky. So we'll have our previous state. We do need to return an object. So if it collides with the apple, we then need to take the current head and push it into the tail, because that way it's going to be updating as well. So let's say our snake also has a tail, and this is like an array that will have rows and columns in it. So if it collides, then we're going to take the current head and put it into the tail. So yeah, so we need to, on our state, we're going to set snake. We're going to need to update the tail. But then we need to think about, should we move it first and then check collision, or should we check collision before we move it? I don't know. Let's just see what happens. We'll have like tiny little bugs, but it should like move on the screen or whatever. So, so if we collide with the apple, we want to take the current head and put it into the tail. So we'll grab the head here. So tail is going to be an array that has all the previous values. So does the head go to the back of the tail or the front of the tail? Front? Yes, front. Okay, so we'll take the rest of the tail and we'll put the head in front of it. Okay? And then we need to move the apple, right? So we should probably put this in a function, but really we can just do this. So we put the tail in to the thingy, and okay, so in both of my state updates, I'm losing all of the data of the snake. So
like you'll notice on lines 47 through 51, I'm updating the snake and updating the head, but because we're in React, we need all of the previous properties. So we still need the velocity and we still need the tail, which I'm not including. So let me leave a note of that. State updates should like spread snake, like ... snake. Because right now I'm losing all of those properties. And then there's another bug. Maybe I catch it in the video, I don't know, but X should be columns, not rows. So my logic here for moving the head is wrong. It should actually be, moving snake, the row is the Y velocity, and the column is the X velocity. I have that swapped. Okay. There's another bug. Let me see if it shows up on the screen. Yeah, then we need to, here. Maybe I fix it, but tail and head are actually on snake, so when I destructure the previous state, I need to pull in snake, not tail and head. So, let's see. When destructuring prev state, use snake, not tail and head, because tail and head are on snake. Okay, let's keep going. What? Anything? I mean, and like one thing I'm thinking is we will need to iterate over the tail and update its velocity as well. That's one thing we'll need to do. We got 2 minutes. I think we can do it. But otherwise, we got to implement these functions. Okay, so is off edge. Did somebody say something? Like, am I missing something?
Nope, we're all just being nice and quiet,
letting me do my thing. Cool. Okay, so if it's off the edge, to check if it's off the edge, we'll say if, let's grab the snake off of state. We'll then say if snake, well, let's grab, yeah, snake.head.column is greater than 19, or snake.head.column is less than 0, or snake.head.row is greater than 19, or if snake.head.row is less than 0. We will return true, otherwise it returns undefined. So we have, double check my logic. I'm doing that next. So if it's off the edge, set game over to true. Yeah? Okay. If it collides with the apple. So we'll say collides with apple. Got a minute. So it's gonna mainly work, and then maybe you'll give me like an extra 2 minutes. Actually, I'm not bound by time, am I? I have like 5 more minutes after that. I don't know. I have till 10 technically, but I want to get this done. Okay, so if it collides with the apple, we can grab the apple off of the state. So if apple.row is equal to snake.head.row, and if apple.column is equal to snake.head.column, then it returns true. Yeah? Peer code review. Yes, yes. Okay. If this doesn't work, it's your fault. That's the issue here. Okay, so if it collides with the apple, then we're going to push it in. I think we have a game here, right? Oh no, we need to be able to move it around, right? That's the tail. That's the thing that we're working on. This thing. That's the rest of the tail. Okay. I'm gonna give myself an extra 5 minutes. Who wants to give me 5 minutes? Okay, cool. No, I'm not accounting for that. I definitely need to count for that. So let's just, let's do that right now. So we'll do something like, we need to grab game over. So if game over is true, then we'll just throw like an H1 that says game over. And then maybe we throw in like the score. Well, I'm just gonna hide the grid. I'm just gonna remove it. So you scored, and then we'll do, we'll grab the snake, grab the snake from state, and we'll say you scored snake dot tail dot length. +1 because the head. Thank you. Yes. So, and actually, let me handle that in here because right now I'm just in the game loop. I'm moving it, but really at the top we can just say like if this dot state dot game over, return. So that way, if it called itself, it won't call it again. Cool. So we have if the game is over, you scored that. Otherwise, we will show the grid, and so that way that'll just completely remove the grid from the page to there, like that. I think that's okay. And now we just need to handle the tail, right? So like on the updates, we need to move the tail along with velocity as well, right? Yeah. Let's take a drink of water. Okay. And so we kind of did that here. We're incrementing it here. And so then tail, similar idea. We'll do like tail.map. That's going to give us each cell. So it'll be snake.tail.map. Each cell. And then for each cell, we're going to return the row is going to be cell.row plus the snake's velocity. Is it plus velocity? I think this is where things get tricky. Well, so if you think about it, we have an entire array. So like, I don't have a whiteboard. I don't know, but the snake is length 3 and it's moving up. So if the head just increased, y velocity is decreased, so it's going up. So the head goes up, and then each one needs to go up by 1. But then if I go right, now my velocity is, so it needs to be, or I could just remove the last one every time, right? Because we have that in our tail. Because it'll be the end of the tail. So it'll be the whole tail except for the last one. Yeah? I like it. So we'll do like tail.slice, tail.length. So I gotta look up how slice works, but it's from 0 to what you want to go to. We'll say tail.length -1. Actually, I could do this. Say tail.pop, right? And then spread the tail, because then it'll be missing from the tail. Yeah? Why not? Okay, we got a minute. And so we're going to update the tail. It's going to be cell.row plus snake velocity x, cell.column plus snake velocity y. We should not update the location of the tail. So I have my logic, I think I have my logic flipped here. So basically we should be pushing the head into the tail every time because it has like the previous location. And then we always pop off of the tail. But then if you collided with the apple, you don't pop off the tail, which makes it one longer. So we need to update some things. So first, don't change tail with velocity. And then the other thing is pop off tail every time except when colliding with apple. And the idea there is like the tail is going to get longer and longer, but every time the head is updating and you're taking the previous head and putting it in the tail. So the first part of the tail is where the head previously was. And that gets pushed in, and then you just remove the last one. So the end of the tail is disappearing. But when you collide with an apple, you keep one and you don't pop it off, and that makes it increase in length, I think. Let's say that's how it works. Okay. Okay, we have 1 minute to review this code. Please find something wrong with it. Hopefully it works. I don't know. Hopefully we don't have any syntax errors or anything like that.
Did we set it so we could use shapes to,
Oh, we didn't use shape detection. Oh, I mean, I don't know. We built a snake app. Come on, I don't know. Apologies, we did not use the shape detection app. Okay, so we grew the snake. We were re-adding it. I feel like the logic's there. Okay, so let's review what's happening here. When it starts up, we build up our grid. Cool. We then have our state that has the apple, which will show up randomly. We have our snake, which is going to start in the center of the screen. Oh, we're not able to change the direction or velocity of the snake. I need to do that really quick. Cool. We have head, we have velocity, we have tail. We're updating everything. Let's handle this in the last 2 minutes, and then we'll see if our app works. Okay, so I guess we could probably do this in the game loop. Is there a way of saying keyboard is key down, or are we gonna have to listen for key events and set it on state? Ideas? Key events. Okay, so when the component mounts, we're gonna just do shape detection. Document.add event listener for, oh, that's not how that works. We're in React. Okay, sorry. We'll do it on the div here. Yeah, so we'll say on key down, on key up, key down. Okay. This dot set velocity. And then we need, oh, we don't have an is_tail. Okay, sorry. We'll handle that in a second. So we need, what's that? Yes, define the arrow key, but we need to set the arrow key. So this is gonna give us the event, and then we'll have event.keycode, right? So if event.keycode is equal to something, up, down, left, right. Wes Boss has this website. It's keycodes.io, I think. No? Am I on the internet? JavaScript keycodes. Keycode.info? All right, up. That's 38. Okay, so if event.keycode is 38, then we're gonna change the velocity. Else, so let's leave a comment. This is up. Else, if the event.keycode is down, which is 40. Wait, arrow down. Yeah. 40. It's down. Else, if event.key, I have 4 minutes. Okay, if event.keycode is right, that's 39. Else, if event.keycode is left, that's 37. Then we need to set the state. What's happening? Oh, this is in a comment, sorry. I'm sorry, what is it? Yes, it is, thank you. Okay, so if we're going up, we need to change the snake's velocity. So we'll do this.setState. We need to update the snake. We do need the previous state, so we'll do previous state. Update the snake. We need to update its velocity. And the x velocity is now going to be 0, and the y velocity is now going to be 1. Cool. Am I going way over time? Do I need to quit right now?
Yes.
Okay, sorry. Down will be -1, and then right will be 1, and then this will be -1. Okay.
X -1, Y 0.
For down?
For left.
Left. Sorry. Okay, and then lastly, we gotta handle the tail, and then we're done. Okay, I'm pretty sure I had the logic flipped. the code isn't on the screen, but for the key presses for Y. So the grid is essentially 0, 0, and then increasing. So if we need to be going up, then Y needs to be decreasing. So up direction, Y is -1, and in the down direction, Y is +1 because it's increasing, because the origin is 0, 0. Okay. We're done, and it's just gonna work instantly. Won't that be great? Okay, so is tail. So if snake.head, if snake.tail.find, we're gonna get the cell, the intail. I don't know. So if intail.row is equal to cell.row, and intail.column is equal to cell.column. It's in the tail, and then we'll give it the tail class. Okay, so else this dot is tail with the cell, then we give it the tail class, otherwise nothing. Okay, this is it. Here we go. We're going to start up the app for the first time. Okay, nothing shows up on the screen. Cannot read property X of undefined. Did I spell velocity wrong? Oh, it's, oh, God. I'm pulling the snake from previous state, right? Velocity. Snake.velocity.
You got 30 seconds.
I'm sorry, guys. I'm so sorry. Okay, let's just do this. Prestate.snake. Here. Oh, wait, is velocity on the snake? It is. Okay, okay. We got this. And then we need to do that down here, too. No, we don't. Can't read property X. For whatever reason, our snake on previous state is undefined. We didn't get anything on the screen. I will push this to GitHub, and I will fix it. But thank you all for watching. That was super fun. Cool.
People say that extreme programming is pair programming, but in reality, extreme programming is just never looking at your app.
Cool. Yeah, thanks for coming.
The initial state, that might have been what it was.
All right, CJ, let's move your table.
Yes. Hello. Okay. Now we're going to fix the app. So that was definitely fun. Like, it would be really fun to do live shows like that pretty often. Maybe I could like travel around. That constraint specifically, like Amal had made some suggestions, potentially doing TDD, potentially using something like Redux, where it like will more isolate your state updates, might be easier to logic through. I don't know. I think in the future I might have a constraint that's like you can only run the app after 30 minutes or something like that. Because I mean, I feel like this was potentially less entertaining for the audience, especially people that didn't code as much, because they couldn't see anything. World says, you should have just ended saying nailed it and dropped the mic. I think so. One of my friends suggested I should, at the end of it, instead of even starting up the app, I just play like a Rickroll video. Okay, but I caught quite a few things as we were watching this. And I think it was Wally Oxen suggested I shouldn't run it until I try to fix these things that I caught. Okay. Show the length of the snake. I don't know if I want to do that. I don't know if I want to do that. Okay. Color in CSS should be background. So one mistake I made was in here, these are the color of each individual cell. So it shouldn't be color. It should actually be background. And that should actually highlight the cell. Cool, that's done. Use root in the CSS. So this comes from trying to style this element. In Vue.js, it's ID app. In here, it's ID root. So this should actually be ID root. Okay, so there's that. In our render function, row.map should actually be returned. So if we look at our render function, right about here, we have this row.map inside of a function and nothing is being returned, so nothing would actually show up on the screen. So this needs to be returned. Like that. So ultimately, you'll just get a bunch of divs. Double check the random apple logic. So our apple needs to show up anywhere from 0 to 19. Right now, my logic says math.random, which is a random value between 0 and 1, times 20. So if the random value is 1, the highest value will be 20. So I think this needs to be 19, because that'll give us a random value between 0 and 19. And I was using that here too. So this should be 19. Okay. State updates should spread snake. And I think this is where like the last error was coming from, like because like in, let's see, in this update, because we're not spreading the snake, we're missing velocity and tail. Well, we have tail, but we're missing velocity. So I definitely need to spread the snake, and we can destructure the previous state to include the snake, and then we don't need to do that. Cool. So that is getting all previous values of the snake. And then we need to do the same thing here, get all the previous values of the snake. And this was broken. This should be snake right there. And this should be snake.head and snake.tail. And snake.tail. Okay. So state update should spread snake. They're doing that. Moving a snake. So in our velocity updates, row is y velocity. And column is x velocity because it's horizontal. Okay. When destructuring previous state, use snake, not tail and head. I think I did that. Don't change the tail velocity. Yeah, so in my other bullet points, I'm going to have to update this logic. I'm thinking we can turn this into just one state update instead of two. And the one state update will decide whether or not we pop off the tail. So we have that. Yeah, so here it is. Pop off the tail every time except when colliding with the apple. So let's see how we're doing this. So first, we're updating the location of the snake. And I'm going to take these off because I'm not listening to anything anymore. Oh, wait. About my random numbers. Math.random is inclusive of 0 but not 1, so that actually should be 20. Let's double check on MDN math.random, because if that's the case, then it should be 20. Ah, okay. Because it doesn't include 1, the highest possible value would be 0.99999. Would be 0.9999999. And if you multiply that by 20, you should get 19 point something. Drop the decimal. Okay, so these actually should be 20. Thank you, Amal. Okay, now let's work on our state updating logic. So, I mean, here's what I think. I think every time we need to do this update here, right? We need to update the velocity, like update the location of the head, but then every time we also need to put the head into the tail.
So I think we can move all of this logic into this state update. So let's make this a function that returns that object. But now we essentially do what we were doing down here. So we need to update the tail. So here's what needs to happen. Let's like store this in a variable. So right here we'll say like collides with Apple, and that will be that. And if it collides with the apple, then we need to pop off. Well, then if it doesn't collide with the tail, then we're going to take the tail. If it doesn't collide with the apple, we will pop off the last value of the tail. And then our tail can be what we had down below. It's going to have the head in it, and then all the current values of the tail. So basically every time we're pushing the head into the tail. Oh, I think there's something wrong with that, but let's see. And then we can get rid of this if statement. And this should be snake.head and snake.tail. But, and then we need that other logic. So the apple will have its current location. So if collides with apple, then we need to put it somewhere random. Otherwise, so if it collides with the apple, put it somewhere random. Otherwise, stay where it is. And if it's off the edge, the game is over. Let's double check this logic. So, and wait, let me catch up on the chat. Okay, cool. So if it collides with the apple, we're going to pop off the tail. But I think that creates an issue right here, because then there will always be like one extra thing in the tail because we're always pushing the head in. So what I think we need to do is like store this in a variable. Let's say like next state is that. And then we have this logic after we create the next state. And this will be next state.snake.tail. So basically we increase the length of the tail by pushing the head in. But then afterwards, if you didn't collide with the apple, we pop it off. So like at the beginning, it should remove it. And then we return next state. Okay. I think that covers that. Someone mentioned using on key press. Let's do that here. On key press, set velocity. Okay. Let's double check our directional logic. So in our key press function, where is it? Here. So up should be negative y because we're like the first row is 0 for y, so we should be decreasing. Down should be positive, right should be 1, x should be negative 1. Okay. And here row is y because it's down like this, column is x. Okay. And that's all we have. Did anyone else see anything wrong with this? Let's do one more pass through and see what we got. Okay. We have our initial state. The apple will show up in a random place. We could probably throw this into a function. Let's say like get random apple. And then we'll have a get random apple function. That way we can reuse it. So that'll return that. And then down here we can say this dot get random apple.
That way it's reusable. Okay. We have our game loop. We have a random apple. If it's over, return. If it collides with the apple, we're going to randomize the apple and increase the length of the tail by not popping it off. If it's off the edge, game is over. Let's double check our logic in here. So if it's off the edge, it's colliding with the apple, it is the apple, it is the head, it is the tail. And then down here, if it's an apple, show the apple. If it's the head, show the head. If it's the tail, show the tail. I think I'm gonna flip these. So if the snake goes on top of the apple, you want the apple to disappear and show the head. So we'll have this logic first. That way, it'll show up like when the head of the apple goes on top of the apple, it shows the head and not the apple. Okay. Should we run it? What do you think? Why not? Let's try it. Okay. Yarn start. Here we go. It disappears. But it actually shows up on the screen. That's awesome. Each field in an array or iterator should have a unique key property. Okay, we can fix that. Also, this is ugly. If we look at this, we could increase this. Let's increase the size of the grid. Okay, so at this point, I think it's pretty good. Like it's not technically working. We have a few bugs we need to fix, but we do get a grid on the screen. I think that's pretty good for not running the app and fixing it. And there's a random apple. Let's increase the size of the grid. Let's make this like 800 by 800. What's 800 divided by 20? So then that would make our cells 40. I guess the other thing is if we did the grid as an actual grid, like display grid, then we shouldn't have that weird spacing in between, like all of the rows and columns will show up in their right spot. Quick stretch. Okay. So this should be grid template columns, and this is going to be repeat 20 times 1, and then same thing for rows, so 20 rows and 20 columns. Cool. Let's set up our keys. So this needs a key with like cell row and cell column. Let's do like cell.row, cell.column. It disappears. Okay, let's not start the game loop. So the app starts up. Cool, we have a grid, we have a snake on there. Let's look at our React state. So our apple has random row and random column. We have our grid. We have our snake, which has a head of 9,9, which puts it there. Okay, if we let's call the game loop once, and then not call it again, and see what our state looks like, just so we can debug that. So now our snake has a head. Okay, so this is an issue. I think our velocity update is potentially not working because the column and row are null on the head of the snake. So in our first update, so this should be snake.head.row and snake.head.column. head.column. Okay, it's not disappearing. Let's try our game loop. That's a moving snake. Okay, let's try our arrow keys. Okay, arrow keys are not working. And there's our game over screen. That's awesome. I think like it might be an issue of the like on key press isn't working like we want. So let's do just log the event of the key press, like event.keycode. So the browser is focused. It's not detecting any key presses. We got movement. That's awesome. Okay, let's say React div on key press. Not apparently I've Googled this before or searched it. Add tab index equals 0. That sounds right. Oop. Nothing's happening. You know what? Just to hack it, well, not to hack it, but like, we'll just do a document.add event listener, because that way it'll listen on the whole page. So let's say document.add event listener key press. And when that happens, we will set velocity. Did I call it set velocity? Function still not getting called. Can we do key? Oh, nope. Key down? Whoa, okay. If property key code of undefined. I think that's a good thing. So component did mount is an arrow function. We're calling it in there. It should technically, because they're both arrow functions, it should work, but let's bind it in the constructor. Because, well, you can't bind an arrow function. Oh, I'm not passing in the event. Okay, never mind. We don't need to bind it. Yeah, pass the event. Thank you, Benjamin. And in here, we get the event and we pass in the event. Okay. Whoa! Cannot reproperty row of undefined. Snake.head is undefined? Okay, so this is the function isHead. We're pulling off snake from this.state. Oh! All of these state updates are not including the previous values of the snake. So we got to spread snake everywhere in here. And this, I mean, this is, again, one of those places where the state updates bit me. And it's mainly because I'm not thinking about it. Like, maybe if I was using a library like Immutable.js,
it would have helped because I wouldn't have had to remember to do all that. Okay, here we go. Up. Up! Left. Left. Okay, let's increase the frame rate. Let's do 500 milliseconds. Okay, it's a little faster. We go up. It's gonna eat the snake. There's a tail. Oh my goodness! We got a snake game. There we go. That is awesome. Okay, I'm proud of that. All right, let's see how long I can play. Oh, well, there's a bug. It doesn't die if it hits itself. Well, I guess it's not a bug. We did say at the beginning of the live stream that I wasn't accounting for self-collision. This is a snake game. Cool. Ooh, I like that. Wally Oxen is saying, like, as the score gets higher, the snake moves faster. We could do that. Yeah, so Jan is mentioning the same thing. A higher speed with more tail. Cool. Let's do it. So we have a working game. Let's make it better. So let's say we'll multiply. Well, let's say 1,000 divided by the length of the tail. So when the tail length is 1, it's 1,000. When the tail length is 2, it's 500 milliseconds. That's probably too much. So let's just do this.state.snake.tail.length. Let's say the fastest it'll go is like 200 milliseconds. That might increase like way too fast. Well, the length of the snake eventually is, well, when it starts is 0. So we're dividing by 0 here. Let's say this. If the length of the snake is there, do that. Otherwise, default to 500. Default to 1,000. All right, see what happens. Okay. Slow, very slow, 1 second per. See you later, all. Thanks for tuning in. All right, we got one. Oh, we got one. Okay, it's a little bit faster, maybe. Got 2. Yeah, it's a little faster. It might start off way too slow. I don't know, maybe there's a better way to do this. There's one more. It's moving faster. It's definitely moving faster. It's okay, this is good. Well, that's a good call. Kelly's just mentioning I could just add 1 to the length of the tail, and so I wouldn't have to do that ternary. Yeah, this is decent. Okay, and I think I'll add collision with itself, because that should actually be pretty easy. So if it collides with itself, the game is over. It's interesting though, because like if I'm going right, should I allow them to go left? Because if it tries to go left, it's instantly going to collide with itself. Oh, that's other logic. The apple should not appear inside of the snake. Yeah, it appeared inside of the snake again. Okay, I think I'll do potentially those two things. If you collide with yourself, the game is over, and when we generate an apple, it should not generate inside of the snake. It's getting faster. Cool. Game over. 31. Jason is asking, are you calling the function that is using key press? I'm not calling it. It's only getting called whenever you actually press the keys. So that's getting called. Okay, but we need a function like collides with self. And then we can basically, it'll be very similar to this. Actually, we can, oh no, we can use the isTail function. So we can pass in the head to isTail, and if the head is the tail, game over. Okay. So if it's off the edge, game over. Or let's grab the snake from state. This dot state. So if it's off the edge, or this dot is tail snake dot head. So if the head is the tail, the game is over. And now we can reuse this. And actually, let's use what? Well, I don't know if I want to increase the length by 1. No, I'm gonna keep it the way that is. Let's do, instead of 1,000, 800. Okay, so that should do colliding with itself, and then we also don't want the random apple to appear inside of itself. So we have, I think we do have our getRandomApple function. Yes. There's definitely a better way to do this, but let's just do this. We'll say new apple is going to be that, and we'll grab the existing apple. Oh, no. We'll grab the snake off of state. And I think we can do the same thing. If is tail with the new apple, because the new apple has a row and a column. Quick stretch. Ooh. Oh, and hey, Elka, welcome to the stream. Benjamin is mentioning, what if you hold the key to move and the game speeds up until you release it? I like that. So if the new apple is the tail, then we need to return a new getRandomApple. Else, we need to return a new apple. I mean, I kind of want to put that in a... Is that recursively going to return the wrong thing? No. This logic should handle... I guess we don't need the snake. So, create a new apple. If it's in the tail, or this dot... well, I guess we did need the snake from state. So if snake.head dot row is equal to new apple dot row, and snake.head.column is equal to new apple.column. So this whole thing is in parentheses. Let's
do some new lineage. So if the new apple is either the tail or the head, then get a new one. Otherwise, return that value. Cool. Yeah, Alka is mentioning probably a better way to do this. Get a list of all the cells that aren't the snake and just pick a random one from that. That's definitely a better way to do this, because this could run, and it wouldn't run into an infinite loop, but it could choose everything in the tail a bunch of times over and over again and never pick anything outside of it. Eventually it will. I'm going to just stick with this logic. Can't read property snake of unbind. This dot state? What? In get random apple? Oh, because I'm calling it in the constructor. I don't want to do that. We need initially a random apple. Okay, here we go. Slow poke. Here we go. Okay, it's not inside the tail. Should speed up a little bit. Okay, speeding up a little bit. That is a very slow snake. So it speeds up every time you eat an apple. We could start it a little bit faster, but... I don't know, the logic that Alka was mentioning is probably a lot better, especially if the snake gets really, really long, because at some point the snake might take up more rows and columns than are even available. So the game could potentially freeze while it's searching for a place to put the random apple. And actually, we should... Yeah, so if you collide with yourself, game over. That's cool. I think the other thing is... Alka's mentioning they have a snake game they made. I'll check it out. Okay, and so here's the other thing. So right now I'm going left. If I press right... Oh! Well, that's weird. It should technically collide with itself. I don't know. I'm not going to debug this all night. I think this is awesome for having not run it the whole time. Okay, then it worked. When the length was longer than 2, if I ran into itself, it was a game over. Okay, I think I'm going to call it there. That was super fun. Thanks everyone for tuning in. And for anyone that joined at the end, I actually built this app live at DVLP Denver, and this stream was me just commenting on the live thing, and then at the end we actually fixed the app to work because it didn't work after the live stream. The constraint that I got during the live stream was that I could not run the app until the end. I had to build the whole thing blind and then run it at the end. Cool, and let's check out Alka's snake. Yes. Oh, I've seen this. Yeah, I saw this one when you shared it on... Oh, that's awesome. You shared it on the coding train Slack. Oh, out of bounds. Awesome. Alka's mentioning it should only be able to turn left or right from its perspective. Turning back into itself shouldn't even be possible. That's actually really easy logic to add. Because basically, in our moving function, so we'll say, I mean, really I should be using previous state here, but this should work. If this dot state, well, let's grab the snake. State.
So if snake dot velocity dot, so you can't go up if you're going down. So if velocity dot y is equal to 1, just return. So that will not allow it to go up if it's already going down. And then similar logic here. So if the velocity is -1, meaning it's going down, you can't go, wait. So y means it's already going up. That's not what we want. If it's going, no. Really, it's the opposite of what we're checking. Yeah, I think this is right. I think that should be okay. And then this will be if x is equal to -1. You can't change it to being 1. And same thing here. If x is equal to 1, you can't change it to being -1. So basically, it can't run into itself. I like that. Can we potentially increase the speed of the game? It's gonna get really fast. Okay. Cool, and I'm going up. I can't go down. I'm pressing down, so that works. And if I'm going right, I can't go left. That also works. Cool. Cool. I am proud of this game. Like, I had to build the whole thing without looking at the browser. It's pretty decent for that. Okay, cool. I guess I'll just play this till the end, till I die. Any last comments or questions before we end the stream? And I'll definitely push this up to GitHub, and feel free to make some pull requests. Like if you want to, like make my random Apple logic better, or any other update. Someone mentioned like holding down the arrow keys actually makes it go faster. Oh, game over. Oh, and Wally's mentioning is mine seems slower because it's on a 20x20 versus a 20x20 grid versus what Alka's was. Okay, that was the stream. Thanks everyone for tuning in. Super fun. Like I said, I'll push up the code to GitHub. I'll put the link in the description, and we'll see you next time. I don't have a stream scheduled just yet. Potentially there will be Newbie Tuesdays on. Sorry, not Newbie Tuesdays. Noob Quest on Saturday. It's not final yet, but it might happen. And also Brooks of the Brooks Builds YouTube channel is going to do a guest stream at some point soon. Maybe next week, but maybe sooner than that. There's this one. We paired on a P5 Brick Breaker game a while back. And he has a channel where he actually live streams himself on Twitch, and then he'll re-upload to YouTube. But I'm gonna give him a stream key, and he's gonna stream directly to my channel. But I'll create some events so you know when that's gonna happen. I think he's gonna do an intro to Rust for JavaScript developers, so that will be fun. Yeah, so his is just gonna be a tutorial series. It's not really he may be building something, but it's mainly. You've never heard of Rust before, but you know JavaScript, and he'll talk about Rust and teach the basics of it. Yes. Cool. All right, thanks everyone for tuning in. That was super fun. We'll see you next time. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. Here's this.